the most fascinating water world on Earth, the Great Backwaters, Kerala.
So, oops, what happened? It's not going to the next slide. It's not going to the next slide.
That's the problem, manually.
Okay.
That should do the trick.
Right.
No, it doesn't, so let's try again. Sorry, it's, yeah, I'm gonna crop it, so keep it centered. Can you drag it?
Yeah, I
to the
can.
middle screen? I will press with your screen, in the middle of your screen, I will. Can you give full screen right now? Let's just keep full screen.
Okay.
That's great.
All right. Sorry for that. So I come from India, Kerala, the place which you saw right now. Myself, Rahul Sasi. You should definitely Google about the place. It's the very south of India. It's like 20, for me, it took 20 hours to travel all the way here. And this is my second time in Ekoparty.
My fellow Americans, it is time to strike fear into the hearts of citizenry. Ask not
Unauthorized broadcast.
what your country can do to avert this crisis. The answer is nothing whatsoever. Our military strength is, in this case, useless. Read my lips. The great confident roar of the American progress and growth has come to an end for the vital technology that this nation holds dear. All
Communications.
transportation, the internet, connectivity, electrical power, critical
Utilities.
their fate now rests in our hands.
We will not tire, we will not falter, and we will not fail.
I don't know how they're getting in.
Thank you.
And a happy Independence Day to everyone.
That was creepy.
So that was from the movie Die Hard. How many of you have seen the movie? So this is a movie which inspired me to work on this particular thing, hacking to cable TV networks. So imagine if I or any hacker is able to get control of a TV broadcasting and spread a message that a riot has started in a nearby village. That can cause a lot of panic, right? Or hacking BBC News and stating that Germany lost in the World Cup. That can also create a lot of panic, right? So you can do. So basically, television is one-way medium, unlike the internet. If you can hack into it and stream a news, people are not going to believe it. They cannot question back like the internet. And that is exactly what we're going to show today in today's demonstrations. So in today's talk, we would start with a bit of hacking analog cable networks. And then we will go into the digital video broadcasting, control access television networks, and a bit of introduction to IPTV networks. So these are basically the things which we would hack today. Myself, Rahul Sasi. I work as a security engineer for Citrix. I've been a speaker at a couple of conferences. I'm one of the admin members of a community called Garage for Hackers. How many of you have ever heard about it? Few? All right. So do check out us. I can be found on Twitter with the handle FP1H2S. So Garage for Hackers, it's a community of like-minded people. We have members all across the world, from information security, consulting, reverse engineering, malware analysis, and everything which is related to security, we have members. It's a forum-based community, and I request all the people who are over here to come visit us and share the wonderful ideas you have. So we will start with how it is possible to hack analog cable networks. We'll have a bit of introduction to the architecture, then the introduction of attacks, and then we will move on to the digital cable networks. So analog was what we used to use before. Now it's all replaced by digital cable. So we will explain how the migration of analog to digital took place, the architecture of digital again, and the different ways you can hack it, and the different type of network layer bugs. So this is the very simple architecture of a cable TV network. I mean, each one of us have a TV at our home, and well, this is something we should all be aware of. You simply have a TV broadcasting station which broadcasts the signals to the satellites. Then you have an antenna which you receive the signal from the satellite. The signals which are received from the satellites are sent to a device called IR decoders, integrated receiver decoders. These signals are again sent to the local cable TV operator. So from the local cable TV operator, they send it to your houses, and that's how you watch a TV. I mean, so these are the important architecture of analog network. You have the satellite, you have the dish antennas, which are again at the cable TV operator end. Now the cable TV operator, what they do is they send it to a decoder unit, which converts the RF signals to RF signals to analog signals. The signals are again sent to a QAM device, quantitative amplitude modulation. The modified signals are again amplified, and then they are sent over optical fiber to the local cable TV operator. Now the local cable TV operator, what they do is they use a coaxial cables and send the signals again to your home. So basically, if I am to attack, what you see over here is the antenna farms, which receives the signals from the satellites. Then the thing which I mentioned, the IR decoders. So these simply converts the received RF signals to, once again. Can I have? All right. So now what happens with the IR decoder is once it receives the RF signals, it sends to the first device, that is the integrated receiver decoder. It converts the RF signals to analog signals. The signals are again amplified using an amplifier. That is what you see, amplifier. And then the amplified signals are passed on to a modulator. That is what you see in the second device, which is below. So basically, there are multiple channels, right? There are channels. There's a BBC News. There is a Fox News. There are so many different channels. They all come with a different signal. What is necessary is each of these channels require a particular IR decoder for decoding those signals. So Fox News will have one of these devices. BBC News will have another device like that. And what the cable operator can do is they can modulate each of these received signals to any desired frequency and send it over to your home. Certain channels like national television, which is of a nation, cannot be broadcasted to any desired frequency. Otherwise, the cable TV operator can broadcast a particular frequency to any desired frequency. So having said that, so this is how the IR decoder farm looks like in the cable TV operator end. You can see multiple IR decoders and modulators. Each one of them would be decoding the signals of a particular channel and then modulating it. So maybe the first one would be for Fox News, then for Star News, and then things like that. Once those signals are decoded and modulated, it's sent to a device called QAM, Contrasted Amplitude Modulation. This is basically a combination of phase shift keying and amplitude shift keying. It can send both digital and analog networks on the same string. All right. Oh. I cannot do this. Can I have a presenter view?
Sorry, what?
I'm sorry. Can I have a presenter view?
It's not working?
No. Presenter view. Presenter.
Oh, sorry, let me check.
Yeah.
No, actually, it's changing the resolution. What's going on?
Where can I have it?
There is an option to not change the actually it's changing the resolution, so the system is
Okay, swap. Show presenter view. No? It's not working.
didn't have any.
All right.
So you can let me see.
So I'm sorry, I'm not able to get my presenter view. All right, so basically you have the IR decoders, which is sent to the QAM device. QAM stands for Contrasted Amplitude Modulation, the format which digital cable channels are encoded and transmitted via the television providers. So this is basically we doing our research in an IR decoder farm, the cable TV service head end. So let me explain a bit of QAM modulation. So QAM is both analog and digital modulation. So you can send on the same network, you can send both analog and digital cable streams. It modulates the amplitude of analog waves using AM, ASM, and modulates the amplitude of digital waves using ASK. So now the modulated waves are summed together and send our optical fiber to the local cable TV operator. So what you see over here in this picture, the first one is a QAM device. And what you have below is an amplifier. So once its modulation is done, it's again sent to a amplifier. So the interesting thing about this particular thing is the transmission stream is unencrypted. There is no encryption at all in analog networks, unlike digital. So let's say if I want to hack an analog table, each channel received would be under a particular frequency. So star news would be under a particular frequency. Cable operators, like we said, can modulate it to any desired frequency as they want, like except certain channels like nation channel. The transmission media is radio over fiber. Now what your TV does is the TV tunes into the individual frequency and decodes them and decodes the audio and video and give you the output. So that's what basically your TV does. So if I have to hack an analog network, which one would you think would be the right place to hack? In this diagram, which would be the layer you can easily attack? It's over here, right? You can do an MITM in where the streams actually transmit from the head-end operator, where the local cable TV operator is there. You can actually do an MITM at this particular layer. Well, so basically, you can actually do an MITM since the network is unencrypted. You can get free cable network if you want, or you can actually broadcast your own signals easily in a analog setup. So this is the setup which we had. The devices which we brought was an optical receiver, which actually converts the optical input and converts it to the analog. Then the optical to coaxial output device, an RF modulator, an amplifier, and a signal tapper. All this would cost you like $80 USD, and you can do an MITM. So this is the garage which we are working on. It's kind of pretty messed up. We couldn't even walk from one end to the other end because of all the wires and all those things which we had. So this is what you see is an optical receiver. Like I said, so there is a head-end operator, then there is a local service cable TV service provider. The head-end operator sends the data or the signals over optical fiber to the local cable TV provider. But from so the local cable TV provider, what they do is they don't use optical fiber. They use coaxial cables because it's a little expensive to have optical fiber. So they just simply replace with coaxial fiber. And this could be easily tapped. You can also tap optical fiber, but then the equipments are really expensive. But the equipments for coaxial fiber is very, very cheap. So here is where the input goes. The optical data comes over here. You can have a converter which actually converts the data. And you get a coaxial output, right? So optical data comes in through the receiver, optical receiver. It converts it, sends it to the coaxial output. And then you have this particular device, the MITM tapper, which actually injects your own signals in the frequency you want. So basically, so the process is very simple. If I want, so you're watching BBC News. If I want to swap the channels and make you watch Fox News, all I have to do is find the frequency of BBC News. Let's say it's A, and the Fox News is on frequency B. Now, both these signals are sent over the coaxial wire, right? The TV knows how to decode each of these signals. So channel number 1 would be set to display BBC News. Channel number 2 would be set to display Fox News. As a hacker, if I need to replace these channels, one possibility is to do a man-in-the-middle attack, modulate my videos in the same frequency as that of Fox News. So if you're watching Fox News, I can swap Fox News by sending the same frequency as of Fox News on the wire. So that is basically in theory. And let's see what happens. So in this video, what we're going to show here is, so that is our optical input. That is, these are the amplifiers. And then we have the modulators. We have the modulator. So this modulator is going to broadcast my videos in the frequency that of BBC News. Then you have the coaxial output. So in this video, what happens is this TV is set to receive a particular frequency, let's say frequency A. And I am going to send the same frequency with my own video on the wire to this TV. Based on theory, I should be able to swap the channels, that this should change and my video should come over here. Let's see what happens when we do that. So in a few minutes, the signals would be sent. Instead of replacing this video, it just, it showed this blue screen. I mean, not the blue screen. You see what happens here? You see what happens? Any idea what has happened? Why did the theory did not work? Because there is a collision. A collision occurred. On the same, your TV is actually decoding the frequency A, and now you send the same frequency with your own video. Now the TV can't understand what happens, and a frequency collision occurs. And that is what exactly happens over here. It simply does not work. Well, to avoid collision, you have to do something. You have to actually cut source the original power source. Or you have to chop down the frequency. You can use a device called signal cutter and chop down the frequency of NDTV or the Fox News or whatever news you want to swap, cut it down completely and replace it with your own frequency. That way it would work. So
take YouTube by.
So what happens is 4 months back there was a so we are one of the biggest democratic countries and we have the national elections over there 4 months back. One of the prime minister candidate had an interview on the TV, and this is what we did. At least like 200 houses over there. Okay.
Take YouTube by storm.
Okay.
With an exclusive channel dedicated to the best of Frank. Take YouTube by storm.
Okay.
With an exclusive channel dedicated to the best of Frankie speaking with Arnold Oswald, where you can watch excerpts from the most controversial interviews with all the biggest newsmakers who've taken straight questions from India's most direct and
Hello, null greetings from Garage 4 Hackers. This broadcasting is taken over by us. Knowledge is free and Garage Forum is to Libre knowledge. You may acquire, interpret and apply freely the knowledge you gain from Garage. The knowledge can be reformulated according to one's needs and shared with others for community benefit. Visit us at garage4hackers.com. Have a good time and go.
So that is basically how we can do an MITM on the analog network, which is not a big deal. The big deal is doing it on the digital network, which is what actually we use right now, or what Argentinians use. So like I said, people don't use analog networks anymore. It's replaced by digital network. Yeah. So what happens is all the cable operators which were using analog network actually upgraded their system to the digital network, that is DVB C or IPTV network, which can now transmit encrypted signals. It is no more unencrypted like the analog networks. DVB C is a digital video broadcasting standard. It's an access control mechanism. And IPTV networks are the normal TCP/IP network, which also does the same thing. Now, both these cases, the signals are encrypted. or scrambled before they're sent on the wire. A set-top box-like device is kept on everyone's house, which is used to decode these signals. So what the set-top box does is it simply does a QAM demodulation. The DVB C digital video broadcasting control access set-top boxes works on coaxial cables. So the input of these devices are again coaxial input. IPTV boxes allows internet connectivity. Even you can send internet over the DVB C. And each of the set-top boxes have a unique identity. So the set-top box which you have at your home have an identity either using a MAC address or using a chip, which is actually kept inside the box. So I'll show you a video of So have you seen this? Have you seen these sort of screens on your TV? What you see is the UA. So what you see over here, the UA, the first number, that is the unique identity of your set-top box. And then you can see the manufacturer information and all the other things. This basically, if you do things with your remote, you would be able to see those information. So these set-top boxes works on based on the digital video broadcasting standard. The same standard is used for satellite broadcasting as well. It's based on 64, 128, and 256 QAM modulation. Like I said, QAM is both amplitude and phase shift modulation. A DVB C can actually send audio and video and data over the streams. Same like that, IPTV also enables audio and video services, but actually it needs a TCP/IP network. It uses protocols like HTTP, RSTP to stream videos. IPTV also can carry audio, video, and data over the wire. So this is an architecture, these are the architecture of the entire digital cable networks. We have 3 different layers. You have the digital cable, you have the head end, that is, you have 3 different layers. That is head end, management network, home network. The head end network consists of the satellite content, the IR decoders, the DRM servers. The middlewares or the management networks consist of the billing servers, where all your billing informations are stored. Then the QAM modulator and all those sort of things. Then you have the home network. The home network is where the set-top boxes is. So I basically would look at it into 3 different layers. So this is an overview of the entire network. You have the satellites, which is again in the head end. Then you have the decoders and all those things, which consist of the head end server. Then you have the middleware servers, which consist of the billing, video on demand servers, live broadcasting servers. So these are all computer servers where the streaming actually happens. And then you have the home network where you have the set-top box. So if you are an attacker, which would be the possible location that you will try to attack in this diagram? What are the what all places you can find a threat or possibly attack to get into a digital network? Well, it's obviously the management networks. So these are all the servers, all the operating systems and all the servers which lies in this network. And then you have the home set-top box devices. These are the 2 places you can actually attack and do something interesting. So in today's talk, we would actually explain attacks on the management network as well as the set-top boxes. We would explain how it is possible to hijack billing servers and remotely shut down TVs, or you can attack the firmwares and find bugs and then do interesting things. Well, the management server, the middleware servers, these are actually used to do the billing information. So every month you pay for your TV, right? So someone has to maintain a list of things, list of your billing information. So those are actually stored in these computer servers. It is possible to locate these mother programs, the billing servers. You can actually do a network fingerprinting if you're on an IPTV. But in the case of DVB C networks, I was able to find internet-facing middleware servers. You know why that has happened? When people migrated from analog network to digital network, there are like small operators everywhere in a city. So these operators cannot now afford a digital infrastructure. So what they do is there's a bigger, higher service provider, and this service provider provides services to the local service providers, and that is how your cable works. So for each of these small service provider in your locality, to manage the billing information, they have a centralized server, and that centralized server is always public. So people, the local cable operators can log into these servers and manage the information. And all this. Thank you. Cheers. Thank you. Okay. So if the demos doesn't come out good, I'm drunk. So, like I said, I was able to find middleware servers on the internet. So basically, when I was interested in doing a research on these networks, I started reading about them, and I found a local service provider. I mean, not a local service provider, the service provider of my state, which manages almost 10 lakh plus users. I just Googled their name on the internet, and the second result which came was an IP address, a domain name, which was their billing server. So I started, experimenting with it, and I found a very simple bug. I'm not going to say what bug, and I was able to enter their middleware server. So I'm not going to explain why. So what happened is, when I found this, I was kind of like, amazed, because all what you see over there are the list of customers and their address and their TV's unique identity, and you can actually do a lot of things right now. You can shut down this TV right now. You can reset the TV. A lot of things can be done remotely. So I reported this to the service provider. I had a meeting with them. I told them that this is what I did, and it was a very lazy, very simple bug. I told them that if you can give me 1 more week, I will be able to find more bugs. If I find more bugs, allow me to do pen testing on your network for some time. I'll do it for free, but you have to let me present the findings in a conference or something like that. So they agreed, and that is how all those things which I'm doing right now, that is how I did. So we found a couple of interesting bugs in that week on the web application. One of the bugs was a setup box hijack. So what happens is, if you are in city A and you wanted to go to city B, all those things are under the bigger service provider, right? You can simply transfer the setup box from one city to the other city. For that, they have a mechanism where the operators list all the existing customers, and operator A can transfer the setup box to operator B. The transfer is authenticated based on an access key, and the access key implementation was actually flawed. Can you spot the bug in this particular PHP code? This is one of the pseudo code which we found on the middleware server, where they use an access key provided by the user, and then they authenticate. It's the simple string compare PHP bug. If you pass an array to a string compare operation, certain PHP versions below 5.3, it would actually return a null. So what over here, what the authentication they are checking is, if authenticated is equal to 0, they are not actually doing a true type checking. Since PHP returns a null, the authentication is successful and you are able to actually bypass the code. So we did that, and we were able to demonstrate how it is possible to hijack all the set-top boxes which belongs to, let's say, Brazil, and I can hijack it from Argentina. So over here, you see is the list of all the customers which we did for demonstration. Let me explain to you something interesting. You see this red button over here? If I press this, I can actually shut down the set-top box at your home. The one after that, this one, this is used to reset your set-top box. So there are a lot of operations which you can do right now. Well, you have a lot of interesting information. The phone number of your customer, the address of your customer. So basically, you can locate your girlfriend's set-top box over here and do something really funny. So, so we found another bug which allowed us to do a remote shutdown of their cable TV. Now the shutting down, so they have a CSR of validation, right? I mean, you are not able to simply force an unauthenticated user to do this. And for that, they had a simple CSR of token, and the CSR of token implementation was flawed. So this was what the CSR of token was. They were keeping the CSR of token in JavaScript. And what they do is, they have a security protection for protecting it. They simply check, the very basic problem when you keep the CSR of token in a JavaScript is you can actually steal it cross-domain. For protecting that, they check whether the script is loaded from, let's say, flappybirds.com or cabletvoperator.com. If and only if it's loaded from cabletvoperator.com, it will allow access to the access key. Else, it will reject it. But this can be easily bypassed using the following code. An attacker can still load the JavaScript cross-domain, and he can simply put the code like string.prototype.match, which is the match function which is used to check whether the current domain is the hard-coded domain. Once you put this particular thing, now any request to url.match would return your own data. This way, you would be able to bypass that. And what you see in this video, so basically, if an authenticated admin visits any of the page, we would be able to force him to shut down all the set-top boxes. So this is what is going to happen. So imagine me doing this when you're watching a favorite football match of yours. Would be, you can actually, mass shut down all the devices in a particular region, or anywhere, sitting anywhere in the world. So, all right. So those are the attacks on the middleware servers. Now I said you can attack the set-top boxes as well. Well, so what we started doing is, the DVB C transport stream uses mbug data format for the streaming of videos. And we started fuzzing the mbug transport stream. Also, we started finding logical bugs in the firmware which can be attacked. So, so the mbug fuzzing, it's not something which I would want to talk about right now, because there are so many papers, so many articles on fuzzing an mbug stream. So basically what happens is, if you can find a parsing bug in the setup box, you would be able to attack the setup box users using that particular bug. So we started fuzzing the mbug transport stream. So our fuzzer was simple. We make the first mbug fuzz payloads, send it to a DVB modulator, which actually converts the mbug stream to a DVB C transport stream. Now the transport stream is sent to my setup box, and I had to sit there, watch whether the TV was getting crashed or not. I mean, the setup box was getting crashed or not. So that is how our lazy furser worked. And then we were able to find a couple of bugs. We were able to find, I mean, mbug parsing is like, you can easily find so many bugs when it comes to set-top boxes. We found, so basically all the bugs which we found, you can have code execution, but we didn't really go for that. All of them were, so what happens is when the set-top boxes crashes, it kind of restarts when something like a memory corruption mbug bug is occurred. But the problem right now is how do you, well, you can do this attack from a middleware server, but if I want to do a MITM attack on a digital network, how is it possible? You have a bug, you know a bug there is in the setup box. How is it possible for you to deliver this bug on the setup boxes? Because the transmission channel is encrypted, right? Like I said, it's DVB C, it's not the analog anymore. Well, so we started reading the RFC of DVB C. So DVB can actually provide both audio and video in the transport stream. It can also provide internet, DVB. So multiple channels are combined into a single stream. Now the payload is actually audio plus video plus the stream information. The stream information is like it has information like the program association table. So have you seen this screen on your TV, on your set-top box? Something like which displays all the information of the channels which you have, right? So this is populated by a stream called program association table or program map table, which is a data information which is sent along with the data and audio contents. So this is the transport stream. A stream of DVB C looks like this. It uses mbug as the payload. It can transmit multiple channels combined together. All the channels will go muxed in a single stream. So the mbug is encapsulated, each stream, transport stream is encapsulated in 188 bytes. So if you look at this diagram, the total one stream of DVB-C is 188 bytes. In that 188 bytes, 4 bytes are actually headers, and the rest 84 bytes are the payloads or the audio or data. Now what happens is, this header 4 bytes are not encrypted. Only the data part, which are the mbug transport stream, mbug is encrypted. So this is the very important thing. And the scrambling algorithm is actually a two-phase algorithm. The plain text of the payload is split into 64 blocks of length. The reminder that is lesser than the 64-bit. All blocks except this block is encrypted with a custom block cipher. And in the second phase, a stream cipher using the first block is encrypted again, So that is how the whole encryption works. So it's a two-phase encryption. But the interesting thing is, you don't have to actually decrypt or do an attack on the encryption screen. While going through the RFC, we found that, okay, yeah, by the way, I mentioned, so there are two ways to get the encryption keys. One is it's actually there in the setup box. But if you are going to get the setup box decryption key from the setup box, you would be only able to attack one particular user. You would not be able to attack the entire users. But so we found another interesting solution for this. That is, like I said, there are total 4-byte headers, right? In that 4-byte headers, there are 2 bits which states that the stream is encrypted or not. If one of the two, if both the bits are set to 0, that means the transmission channel is not encrypted. If it's not set to 0, that means the content is encrypted. And this is what all the setup boxes all the set-top boxes are programmed to accept this because this is part of the RFC of DVB C communication. So for attacking a digital cable network, all you have to do is do a MITM attack. When you inject your transport stream, change the bit of change these bits to 0, and now the set-top box thinks that the incoming streams are not encrypted. So basically, instead of sending to the decoding module, it simply sends to the mbug parsing module. So that is how you can do a MITM attack on digital networks. So this is a very simple bug which is there on almost every set-top boxes out there. So having this bug, knowing this bug, you can actually introduce your own DVB C transport streams into any network. So now you have a bug in the set-top boxes which can crash the set-top box. All you have to do is the same thing which we did to analog, inject your own signals, but when you inject the signals, modify the bit such a way, and you can oops. So this can well, crashing something is kind of funny. You know, you can actually crash all the set-top boxes by continuously sending the first payload. But there is something more interesting which you can do. If you have noticed, every time when a set-top box boots up, or when you start the TV, the set-top box, it actually checks with the, it actually authenticates to the home gateway. That authentication happens in the case of IPTV. But in case of DVB C multicast, it uses a protocol called DSM-CC, and it actually gets the firmware from there. So it actually checks the stream to see whether the stream has got an updated firmware or not. If the stream has an updated firmware, this particular protocol can have data along with the stream, and your set-top box will actually decode the firmware, installs it, updates, and restarts. Or in case of IPTV, which uses unicast, it checks for a middleware server for updates. If any is uploaded, it is downloaded via TFTP, reboots and installed. So in the case of DVB C, so I'll show you how the set-top boxes boots. You might have seen this in your TVs actually. When you start your TV, it will show you a logo of your service provider, maybe sometimes. And then it will go to a screen which says tuning in or something like this. It will show for a few seconds. And if you have noticed this, sometimes it says, this says auto update failed. I'm sorry for the video. What it says is auto update failed. That means the set-top box is actually trying to find if a new firmware is available in the DVB C transport stream. If it's available, it will actually decodes and installs it. If it's not available, it shows that particular screen. So this is the protocol which is used to send data or firmware updates in a DVB C transport stream. This is basically an encapsulation of data in mbed format. The applications of this is simply, like I said, it's a firmware update or a set-top box application software download and all those sort of information. So this is how it basically works. You can actually, if it finds a new firmware in the stream, it will actually parses the new firmware. So when it says downloading, and it will install the new firmware. So that is what actually is happening. So we have three things here. We have a mbug parsing bug, which can actually crash a set-top box. If it crashes, it restarts. When it restarts, it checks whether a new firmware is available. So it checks whether a new firmware is available. So now we have the other bug. Remember the MITM attack on digital networks? We have the second bug, so we can inject your own signals into the stream using the second bug. So combining this together, what we did is we downloaded a copy of their firmware. Remember this video which you saw? And there is a logo of the service provider, right? When it starts, there's a logo of service provider which is displayed. We replaced this logo with our own image and crafted our own firmware. So basically, the demonstration which we did to them, what happens is we made the set-top boxes update with our own firmware when it restarts using the MITM bug. So next time, and you can do it on masses. So next time your TV starts, it will start like this. When your set-top boxes starts, instead of the logo, it shows this. So that's all what we did. There are a few other things which we are not allowed to talk. These are the only bugs which they gave me permission to talk. There are a few things which were not fixed. There are a few things which is really complicated for them to fix. But yeah, so that's all what we have.
Muchas gracias, Rahul. Thank you, man.
Thank you.